this video is on midpoint formula, finding the end point of using midpoint, and also finding the distance between 2 points. So first question is, what is a midpoint? Midpoint is if you are cutting a sandwich in half, let's say it was an 8-inch sub, the halfway point would be in the direct middle, so that's why it's the midpoint. So you would cut it into half and creating two 4-inch subs. So if we extend that into coordinates, we can have two coordinates called J and K. So we have segment JK, and we're going to cut that in half. So our midpoint would be point M because it's directly in the middle of J and K, points J and K. When that happens, you have created two new segments, which is called segment JM and segment KM. These two segments are the exact same length, just like this sub was 4 inches and 4 inches. So the entire length was 8 inches. So we can see that the midpoint of M is directly in the middle of those two. So we have 4 inches here and 4 inches there. If we don't know any values, we can also just say that segment JM is congruent to segment KM. And the tick marks here, one tick mark here, one tick mark here, tells us that those are congruent. Congruent means same shape and same size. So because they are both line segment, same shape, because they are the exact same distance away from M, so they are quote unquote 4 inches away from each other, or from M, so this is 4 inches long, this is 4 inches long, they have the same size. So the same size goes with the equal sign, and the same shape goes with the tilde above the equals. So what is the midpoint formula, and what does midpoint do? So when we look at it on a graph, midpoint is an actual location, so it is a point. So it is a location on the graph. It is a singular coordinate. So we write our answer as an x, y answer. So the formula is when we have two coordinates, we use x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. So we are finding the average of the two x values we have. So we have two x values, and average is add them up and divide by how many you have. So we only have two coordinates, so we'll add the two x's up and divide by 2. Comma, because it is a coordinate, you are finding the x of your midpoint, and then you're going to do the same with your y's. You're going to take both of your y values, you're going to add them, no matter if they're positives or negatives, you're going to combine them as they are, and then you're going to divide by 2, because I need to know halfway. And that will give us our y value of our midpoint. So we have x sub 1 plus x sub 2 divided by 2 gives us x sub m for midpoint. Y sub 1 plus y sub 2 divided by 2 gives us y sub m for the midpoint. For an example, we have segment AB has endpoints at 7, 3 and negative 5, 5. We're going to plot point M, then midpoint of segment AB. So let's find that on the graph real quick. So 7, 3 would be here, and let's call that point A. And then negative 5, 5, so negative 5 on the x, 5 on the y. This is point B. Now there are always two ways to do formulas. You can use the full-on formula, or you can do it a different way. You can always figure out where the formula comes from. So I'm going to show the formula first. So as a reminder, our formula was x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. So we have our x's of 7 and negative 5. We have our y's of 3 and 5. So it does not matter which one you say is x sub 1 and x sub 2, because as long as you're adding them, as long as you're consistent and you're adding them, you're going to get the same answer, because addition is commutative. So in this case, I'm going to use my 7, 3 is going to be my first coordinate that I use. So in my midpoint formula, my first x value is 7. plus my next x value is negative 5. So even though it says 7 plus negative 5, I write it exactly as it is. Divide by 2, comma. I'm going to do the same with my y's. So since I started with the 7, I'm going to start with the 3 on the y. So I have 3 plus my y sub 2 would be 5. And we have to divide by 2 because we're doing halfway. Now we have to simplify this. So we have 7 plus negative 5 really just means 7 minus 5. So that's 2, and we divide by 2, comma. 3 plus 5 is 8, and we still have to divide by 2. So we still need to simplify this. 2 divided by 2 is 1, and 8 divided by 2 is 4. So our midpoint for m is 1, 4. So if I come over 1, 4, this would be m. So if I were to connect these, B to A, I go through point M, and B to M and A to M will be the same distance. So using the formula, we can see where they will be plotted at. And we can see that M is going to be in the middle of this. And again, there's always another way of figuring out how to find midpoint. And so I'm going to show another way. This is the same problem, but I am not going to graph it this time. I am also not going to do the formula. Okay? I'm going to look at my coordinates in a table. So I'm going to write it out as x, y. I have 7, 3, and I have negative 5, 5. I know that this is A and this is B, and I need to know M. Well, I know that I need this coordinate of x, which has to be between 7 and negative 5, and my y has to be between 3 and 5. So if I want to do this, it's not going to be a constant rate of change. I'm not finding slope. I need to know how far away 7 is to negative 5. So from 7 to negative 5, I would go down 12 steps. And then, since it's halfway, I would have to divide by 2 as normal. Well, that's negative 6. That means that to go from 7 minus 6 gives me a positive 1. That will be the x value of our midpoint. So if I do the same thing for the y's, how do I get from 3 to 5? Well, from 3 to 5, that's going to be adding 2. So I'm going to add 2, but then I have to have half of it because I have to go in the middle of that. And that would be a positive 1. So technically from 3 to the next bit, I'm going to add 1. So 3 plus 1 is 4. That's the y value of our midpoint. And that is the same midpoint that we had when we used the midpoint formula. There's always 2 ways to do things, at least 2 ways. So we have seen it as numbers on a number line. What is the exact middle of 7 and negative 5 is 1. You can also see this on a number line. So if I go to 7 on our x and negative 5 on our x, we can count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and I'm still not met yet. I count 1 more, and I count 1 more, and I meet. So 1 is the x value of our midpoint. I can then do the same thing using my y values. So I'm going to erase this. But I'm going to do the y values the same way, but still on this number line as the x coordinate, only because I'm doing it on the x-axis. I'm not making it my x coordinate. I'm just using my 3 and 5 on a number line. So I'll have 3 and 5. So the exact middle of 3 to 5 is 4, which was the y value. So I still have 1, 4. So we're going to extend that to find, using the midpoint formula, segment TN has a midpoint at negative 3, negative 4, but T has coordinates at negative 6, negative 9, and it says find the coordinates of N. So we actually have one endpoint, but not the second endpoint. So we don't know that. But we do have the midpoint. So if we think about what this might look like, this could look like, here's point T. We have point M. We do not have point N. That's our question. So we can figure out how far this is to figure out how far that is. So we are trying to figure out that entire section so we can figure out the location of point N. So let's use our midpoint formula. Of x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2 is again equal to that x sub m, comma, y sub m, because this represents the midpoint. So let's plug in our numbers. This is your midpoint. So our midpoint x value is -3. So that comes, I'm going to rewrite this. I know that this is going to be a fraction divided by 2. This is going to be a fraction divided by 2. I don't know what goes in here yet because those are variables. Equals, I know this is going to be parentheses, comma. So this x value of -3 goes for the midpoint. So that's going to be the x midpoint, -3. The -4, again, is the midpoint y value. So that's going to go here. Then we have another coordinate of x, but this is for coordinate t. T has the -6 for the x. So I'll use that as x sub 1. So that's -6. There is no other x in this entire problem, so I don't have x sub 2, so I'm going to put plus x sub 2. Now the sub 2 is just noting that it's a different x value, so if you want to put it as just x without a subscript, you can do that. We still have the y value of -9. And that again goes for coordinate t, which we use for the x sub 1, so we're going to use for y sub 1 as well. So we have -9 plus, there's no other y value, so we know that's going to be plus y sub 2. This is what we have, so we have to actually solve. Now because this is an equation, we can actually utilize the x values equal to the x values. So I'm going to write that out as -6 plus x, I'm just going to write it as x for now, divided by 2 is equal to the -3. We can do the same thing with the y coordinate is equal to the y coordinate because they have to match up. So we'll write this out as another equation of -9 plus y, and again, I'm going to leave off the subscript, divided by 2 is now equal to -4. So to do this math, let's focus on the x's. Let's get rid of the fraction, so I'm going to multiply both sides by 2. So again, -6 plus x is equal to -6. Now I'm going to add 6 to both sides. And I'm going to have x is equal to 0. So that should be the x value of one of our coordinate n. So we're going to have n is at coordinate 0, comma. Next, we're going to solve for y. So again, I'm going to multiply both sides by 2 to get rid of this fraction. And we have -9 plus y is equal to -8. Then we're going to add 9 to both sides. We're going to have y equals -8 plus 9 is +1. So the y value of our coordinate is +1. That means that our endpoint should be at 0, 1 for n. So let's plot that. And we can see what it'll look like on the coordinate plane. So our t, which is our first endpoint, is at -6, -9. So this is coordinate t. Coordinate m, which is our midpoint, is at -3, -4. And we can see that this is going in this direction. So there's t to m. Now m to n should be the same distance because m is the midpoint. So let's plot 0, 1. 0, 1 is n. This is the same line from t to m. They are congruent. And that's how we can find, using the midpoint formula, we can find an extra end point. Well, that seemed like a lot of math. So is there another way we can look at this? Absolutely. So we're going to look at this exact same problem, but we're going to do it in a different way. I, again, am going to write this out as a table of values. So x, y. I know I have t and I have n, but I know my midpoint is in the middle of m. So I know I have t here is coordinate -6, -9. I have the midpoint, so I'm going to call that m, at -3, -4, which is right here. Now, just like I did earlier with the midpoint, I can find how much space is between them. Now, I can see that from -6 to -3, I'm actually adding 3 values. Well, because it's in the exact middle, I have to make sure that this length is the same as this length. So I'm just going to add 3. Well, -3 plus 3 is 0. So the n has an x value of 0. Let's do the same thing on the y. From -9 to -4 is adding 5 steps. Well, again, since it's the midpoint, I know that from t to m has to be the same value from m to n. So this has to also be plus 5. So I read it as -4 plus 5. -4 plus 5 is +1. So my end point is at 0, 1. It's the exact same answer we had on the last one. We can also look, I'm going to go back to the last one. We can look at our coordinate plane and we can do our slope. I just wanted to show this, that our change in y from t to m, change in y, 1, 2, 3, 4, 5. Change in y is equal to 5 over change in x is 1, 2, 3, +3. So we have +5 and +3 from t to m. So if our values are the same here, our slope should also be the same. So if we go from m to n, change in y, 1, 2, 3, 4, 5. So change in y is also +5. And our change in x is 1, 2, 3. Also a +3. So our slopes are also the same. So we added 5 and added 3. And that's the same thing that I did with my table. So midpoint, you can use a formula, or you can see what it looks like on the actual graph and make it make sense. So the next up, we have distance. What is distance? Distance is the length from start to finish. Like if we're having a race, the 100 meters is the length of how much you're running. It could be the distance from a location to another location. So there are 502 miles from San Diego to San Francisco. So it's the length that you are driving all the way. Distance can also be measured with a ruler. So when we have distance in this ruler here, we can see that from C to K is 13 centimeters. So the distance between 2 points is always a length of value. So when we're talking about coordinates, we still have to recognize that distance is a measure of length. So we must have units on it. That could be centimeters, inches, miles, or you could just use the word units. So it might be 15 units in length. Where is distance come from? What is distance formula? We have a formula here which says the square root of x sub 2 minus x sub 1 squared plus quantity y sub 2 minus y sub 1 squared. Okay, well that's a whole nother formula. But where does it actually come from? Distance between 2 points, if I want to find the distance between these 2 points, it almost looks like it's forming the horribly drawn right triangle. And it comes from the Pythagorean theorem. The distance formula is derived from the Pythagorean theorem. It would be c squared equals a squared plus b squared. So I have the squared symbols. I have the squared symbol. Where's the square root come from? Well, how do we get c by itself? We would take the square root. C is equal to the square root of a squared plus b squared. So the distance formula, it actually comes from Pythagorean theorem. So let's do an example. We're going to do both the distance formula and the other way. We're going to find the length of segment AB. Okay, so we have coordinate A is at 3, 7, and coordinate B is at 7, 4. So I'm going to use the distance formula for this. So our distance is equal to the square root of parentheses. So we have x, y, x, y. Again, it does not matter if you do x sub 1 and then x sub 2 here or vice versa. So I will put my first coordinate as x sub 1 and y sub 1. So it does matter if you, when you're subtracting, that you have to have these parentheses. Because if you don't have parentheses and you square it, a positive squared is positive, but a negative without parentheses. So if you do negative 2 squared, only the 2 is being squared. So when you are doing this, you have to make sure that you have these parentheses if you're using the formula. So x sub 2 is 7 minus x sub 1 is 3, parentheses, squared, plus, parentheses, y sub 2 is 4, minus y sub 1 is 7, close parentheses, squared. We're taking the square root of all of this. So mathematically, we are doing distance equals the square root of 7 minus 3 is 4 squared plus 4 minus 7 is negative 3 squared. We're going to keep doing the math of this. Distance is equal to the square root of 4 squared is 16 plus negative 3, quantity negative 3 squared is positive 9. I keep going. Distance equals the square root of 16 plus 9 is 25. And then the square root of 25 is 5. So the distance is equal to 5 units. As soon as you see the word length, that tells us that we are using distance and that we must have the word units or whatever unit of measure we have. So our distance using the distance formula is 5 units. Now, let's do that same problem, but using the Pythagorean theorem. So instead of seeing all of this, I'm going to use the derivation of the Pythagorean theorem, which, as a reminder, it was c squared equals a squared plus b squared. So I'm really just finding the hypotenuse. So it's really just c equals the square root of a squared plus b squared. I'm just finding the hypotenuse. So I want to take this value, on this graph over here, I'm going to create a right triangle. And now I just need to know the length of this vertical line and this horizontal line, which you can count. You cannot count, diagonally, which is why we have to find the distance mathematically. You can count vertically and horizontally. So vertically, how far is this? This is just 1, 2, 3 blocks away. That's 3. Well, for our B, again, for this right triangle, we have 1, 2, 3, 4 blocks away. Well, let's just do the Pythagorean theorem. We have 3 squared 4 squared is equal to c squared. 3 squared is 9. 4 squared is 16 equals c squared. We still need to finish this. 9 plus 16 is 25. And we still have to find the hypotenuse because this is not c squared, this is c, so we have to get rid of the square. So we need to square root both sides, and we get c is equal to the square root of 25 is 5. So again, the distance is equal to 5 units. So the distance formula is great to use, but it comes from the Pythagorean theorem already. So we can just use the Pythagorean theorem on this. Anytime we have a diagonal line that we need to find the distance of, you can just create right triangles and do Pythagorean theorem. Thank you for watching. I hope this made sense.